All right, students, we're going to start Unit 6, Section 1, talking about integer exponents. All right, and we did do a little bit of this at the beginning of the year with some of our DMRs, laws of exponents. But let's do a review here, okay? You have seen positive exponents. For example, 3 squared is a positive exponent. You all should know that 3 is your base and 2 is your exponent, okay? And what you do is you take 3 and you use it as a factor of 2. So you're taking 3 times 3 and you're getting 9, okay? Now, what happens when the exponent is negative or 0? Do you understand what we do and why we get the answer when they're negative and 0? So that's what I'm going to show you right here at this table. Let's start out with 5 raised to the power of 5. Well, guys, that's just 5 times 5 times 5 times 5 times 5. And when you do that, you get 3,125. 5 to the 4th, so that would just be 5 times 5 times 5 times 5. And when you get that, you get 625. 5 cubed, which is 5 times 5 times 5, 125. 5 squared, 25. 5 to the 1st, 5. Now, this is where it gets a little confusing. So what we're going to do is we're going to look at how we can find a pattern to prove, and this is what you're going to do in geometry next year, prove what 5 to the 0 power is, and 5 to the negative 1st power, and 5 to the negative 2nd power. Okay? So, how do we get from here to here, or here to here, or here to here? Well, I can immediately see from here, how do I get from 25 to 5? I am dividing by 5. So let's see if that's the pattern. Let's back up. What's 3,125 divided by 5? You get 625. What's 625 divided by 5? You get 125. What's 125 divided by 5? You get 25. 25 divided by 5 is 5. So, let's continue this pattern here. What's 5 divided by 5? 1. What's 1 divided by 5? 1 over 5. What's 1 over 5 divided by 5? 1 over 25. Okay? So, students always ask, Ms. McCrory, how come when you have a base raised to the 0 power, it's always 1? Well, here's why, because of the pattern. Anything raised to the 0 power is going to be 1. Unless it's 0. You can't have 0 raised to the 0 power, okay? So, let's look at this and see if we can come up with a rule for negative exponents here. So, if we have 5 to the negative 1st, that's 1/5, because we just took 1 and divided by 5. That is the same as 1 over 5 to the 1st power, right? So, what about this one? 5 to the negative 2nd is 1 over 5 squared, because 5 times 5 is 25. So do you all see the rule for negative exponents? What you do for negative exponents is you put it over 1 and you flip it. And when you flip it, that exponent is now positive. So 3 squared is 1 over 9. Okay? This is just your 0 exponent. Anything raised to the 0 power is 1, except x can't be 0. And then anytime you have a negative exponent, you flip it, change your exponent to a positive, and then simplify. And if you want to know why, it's a little off right now, but here's why, because of the pattern. All right, so let's apply some of this. Okay, we have 1 cup, and it is 2 to the negative 4th power gallons. Simplify this expression, okay? So we have 2 to the negative 4. So that's 1 over 2 to the 4th power, which is 1 over 2 times 2 times 2 times 2. Guys, you can do this mentally. 4 times 4 is 16. And we are talking about gallons. So when you simplify to the negative 4th gallons, you get 1 over 16, 1/16 gallon. All right, on this one we have a sandfly with a wingspan of 5 to the negative 3rd power. So, put that over 1, change your exponent to positive, simplify, and don't forget your units because we're talking about length of wingspan. All right. Now, let's go ahead and simplify these. 4 to the negative 3rd. Anytime you have a base raised to the 0, unless the base is 0, your answer is 1. Now, guys, on 5 and 6, you need to be very careful. Can you tell the difference between 5 and 6? On 5, your base is negative 5 inside the parentheses. On 6, your base is actually just 5. So let's look at this one first, number 5 first, okay? So if our base is negative 5, when we flip that, you need to keep negative 5 inside parentheses. Because what you're doing on this one is you're taking negative 5 times negative 5 times negative 5 times negative 5. And you get 1 over 625. Okay? So when your base is inside parentheses, keep it inside parentheses. On this one, your base is just 5. The negative is not part of that base. On this one, the negative is. So on this one, what this is saying the opposite of 5 raised to the negative 4th. So the opposite of 1 over 5 to the 4th, opposite of 1 over 625. See the difference? Most students will make their errors on these two because they're not looking closely at what the base is here. The base here, the negative is included. On this one, the base is just 5, and this is saying the opposite of 5 raised to the negative 4th power, which is going to give you a negative. All right, last one. Oh, no, not last one, sorry. Now what we're going to do is we're going to substitute in, okay? So we have x to the negative 4th power, and we want to substitute 4 in for your variable x. So that's what we're going to do first. Substitute 4 in for your variable x. So that's 4 to the negative 2nd power. It's negative. So you want to put it over 1 and flip it. That exponent is now positive. And then 4 times 4 is 16. All right, now we're going to substitute in for a and b. So I have negative 2, a to the 0, b to the negative 4. All right, so I have negative 2, a is 5, b is negative 3. Be careful, students. Make sure that your b is inside parentheses, your negative 3 is inside parentheses, because that's what your base is. That negative is part of your base. All right. So I'm I'm going to move it over here. We have negative 2. What is 5 to the 0 power? 1. What is negative 3 to the negative 4th power? 1 over negative 3 to the 4th power. Okay, so negative 2 times 1 is negative 2. 1 over negative 3 to the 4th power, this is negative 3 times negative 3 times negative 3 times negative 3. So I have negative 2 times 1 over, well, that's positive 9 over 81. Keep going, we can simplify more. So make this negative 2 a fraction, so I have negative 2 over 81 as my final answer there. Okay, number 9. 7 times w to the negative 4th. So that's 7 times 1 over w to the 4th. 7 over w to the 4th. Okay? Now on 10, I have negative 5 divided by k to the negative 2nd power. So that's negative 5. Let's keep that divide. Let's go ahead and convert that to 1 over k squared. Now, we don't divide fractions. We always multiply by its reciprocal. So that's negative 5 times k squared over 1. So when I simplify this expression all the way out, I get negative 5 k squared. All right, for 11, we have a to the 0, b to the negative 2, over c to the negative 3, and d to the 6. All right, now let's go back to number 10 here. If you all notice, when we start with a negative exponent as the denominator, our final answer was we moved it to the top with a positive exponent. So let's look at this one here, okay? A to the 0 is 1. B to the negative 2 is going to go to the bottom. And then you're going to change that exponent to a positive, okay? C to the negative 3 is going to go to the top. And you're going to change that exponent to a positive. D to the 6 stays on the bottom. Okay? If you don't see it this way, you can multiply it out, do your computation this way, but what you want to understand is when you have negative exponents in a fraction here, they just switch. All right, let's do one more before we run out of time. We have 2r to the 0, m to the negative 3. Okay? So, that is 2 times r to the 0 is 1, and then let's put our fraction bar. M to the negative 3 is going to move to the bottom as the denominator, and your exponent is now positive. So that's 2 over m cubed. Okay, guys, that's it. Have a good day.